Hi, this is Scott from RedmondPhysicsTutoring.com, and in this video I'm going to show you a couple of hacks that you can use to help you visualize the three-dimensional nature when you have charged particles moving with a certain velocity through a magnetic field, and you have to find the force, which is the cross product of those two things. Until this part of the E&M course, you don't necessarily need three-dimensional visualization, but you really have to get it at this point. And I'm just sharing some tricks that I've learned over the years that have helped different students. The first one comes from a drafting course that I took in my undergrad in engineering, and it's basically from drafting. So I have a quick example here. Given a magnetic field that's due north and a velocity of a charged particle, well, say it's a positive particle, that's 30 degrees up from east. So that means that if I have the pen as a vector, it starts out going east, but it's actually 30 degrees, say, towards the camera, or rotated 30 degrees up. Then you have to find the direction of the magnetic field. And this view from the top down doesn't show it very well. We can easily see north, east, south, and west, but if we did the right-hand rule from this, we would get a vector pointing straight up towards us. But that's not actually what happens. So the trick is that you can take a sheet of paper and fold it, and it essentially gives you a window on three different views. So we have the top view, where we see north, east, south, and west. Then we can rotate and look at it from the front, where we still see east and west, and we can also see up and down. Then we can also rotate it to look at it from the side, the right side. So we still see up and down, but now we can see north and south, and that's related to the original drawing, which is now rotated. So we can, from the top view, if we have north to the right, we can rotate, and we see north to the right. And what this is doing is letting you look at the problem in 3D and visualize what's going on. And what you often wanted in drafting was some view where you can see the angle very clearly. And it's actually the front view that shows it the most clearly, where you actually have the velocity 30 degrees up from north, and it turns out then that the force, which is perpendicular to V and perpendicular to B, you get that from the right-hand rule. If we have a positive particle, we start with our fingers going in the direction of V, second finger towards B, and then the thumb gives you the force. The second hack is, it's even simpler in a way. You just go to Dollarama, wherever, any kind of dollar store, Dollarama here in Montreal, and you get some pipe cleaners, and then you can make yourself a three-dimensional coordinate system, right-handed coordinate system. So in this case, I've actually labeled them V, B, and the force on B, and this idea actually came from working at the space agency, where we had a ton of three-dimensional rotations, and we had to constantly think about the orientations. So this was actually something that the astronauts would use when they were being trained to operate the robotic arms on the space station. Not necessarily with pipe cleaners. They had some nice wooden models. But anyway, the pipe cleaners get the point across. One of the nice things about this is that you can rotate it any way. So if you're given a problem where the magnetic field is into the page, then boom, just point that down. The velocity isn't up. Maybe it's off to the right or off to the left. You can just rotate it as you like. One of the other advantages of this is that it clearly shows you that you can have an angle that's not 90 between your velocity and your magnetic field, and as you rotate it around, you still have a force vector that's perpendicular to both the velocity and the magnetic field. As long as that angle isn't 0, where there's essentially no force, or 180, then you can look at any angle between them, and them being the velocity and the magnetic field, and you can get the correct direction for the force. This is quite handy because it saves you from cramping up your hands, moving things all around. And it folds up nicely. If it bends, you can always fix it again. Quite simple. I had a lot of students make these, and I personally allowed them in the exams, but you would, of course, have to ask your own teacher to see if you're allowed that. If not, then I can't imagine what's wrong with taking a piece of scrap paper provided during your exam and folding it yourself so that you can get a couple of different views. Whatever works so that you can understand the 3D visualizations, because that is one of the things that you will need to understand in order to master this part of the course. I really hope this is helpful. It's a very different type of video for me, and again, I really hope that it can help you pass your physics course, and I wish you all the best.